Good. So our next speaker will be Chad Mellison, who is an aquatic biologist for U.S. Fish and Wildlife Service.
All right. Thanks everybody for showing up. It's kind of with a heavy heart. I'd like to talk a little bit about Kent Mcadoo, who unfortunately passed away very recently. Kent was a great guy. Known him since about 2004 when we first started working on Columbia spotted frog conservation. And he was appointed the lead for our group in Northeast Nevada. And being an aquatic biologist myself, I kind of scratched my head like, why did we get some terrestrial range guy to be our lead for spotted frogs? I kind of questioned that, but I quickly changed my tune when I saw what Kent could bring to our group, and just his knowledge of the area and bringing more of a terrestrial slant to a bunch of us aquatic people really helped us out a lot. And I know many of you in this room knew Kent very well, and he'll be sadly missed. So again, Kent was going to give this talk, and some folks called me right after his passing and asked if I could put something together because we couldn't open his computer. So I quickly slammed this paper together, so I hope I make Kent proud with this. So the way this talk's going to go is I'm going to talk a little bit about what the literature tells us about beavers and amphibians in general, and then introduce you to Columbia spotted frogs in the Great Basin and talk about some recent research that David Pilliard, who's standing in the back of the room, did for us in looking at a lot of the habitat for this frog. All right, so this first study is actually from Acadia National Park, kind of far away from where we are here. It was done in 2007, and looked at pond breeding amphibians. And on the y-axis, you see the percent of available breeding sites that are occupied. And the researchers here looked at 3 different species of amphibians and looked to see, are they breeding in active beaver ponds, abandoned beaver ponds, or areas that had no beaver activity. So as you can see, bullfrogs were only found breeding in active beaver ponds. Then you get the wood frog, which had a very mixed results. So some in active, quite a bit in the abandoned, but even more in non-beaver occupied habitats. So a real mixed bag with that species. Then again, the pickerel frog really chose sites that had active or abandoned beavers. So moving a little bit further west, closer to us, Stevens published a paper in 2007 from Alberta, Canada. And he did a similar study where they looked at 3 different species of frogs. 2 different species of frogs and a toad. So your western toad, your chorus frog, and again, our friend the wood frog. And they again looked at unobstructed streams and the beaver ponded streams. And they split theirs out looking at young of year, so that's really a surrogate for looking at breeding. And then the adults of the species, and then those columns on the right are those 2 combined. So young of year and adults combined. And their catch per unit effort you can see on the y-axis. And again, you can see for toads, they were breeding more in beaver-occupied ponds. Chorus frogs are a little bit more terrestrial frog, but they too were finding beaver-occupied habitats to their liking. And then our wood frog, if you remember from Maine, that had a real mixed bag. But in Alberta, they were really choosing beaver-occupied sites. So again, even within the same species, depending on where you're at on the landscape, they can be choosing beaver-occupied areas. So the last study is by Blake Hosick and others, and they were doing, again, a very similar study. This study had a much longer time frame, and I'll show you why that's important here. So the the x-axis for all these slides, all these graphs are the same. It's a 10-year data set, so from about 2001 to 2011. And they looked at 5 different species of amphibians. And they were sampling sites in Glacier National Park, Greater Yellowstone area, and then Rocky Mountain National Park. And they were looking at this exact same thing. Where are we finding these amphibians? And so you might not be able to see it, but the squares are beaver-occupied areas, and then the circles are areas that don't have beavers. So the 2 top slides or graphs are 2 different salamander species. So if you look at the top left, and if you had a short-term study, a 2-year study, typical master's study, you would say, oh man, these salamanders are just choosing beaver-occupied sites to breed in. But if we follow this, let's put these populations through time, you can kind of see those merge, and in reality, those salamanders, both in Glacier and Greater Yellowstone, really aren't differentiating between beaver ponds or not beaver ponds. So again, more species differentiation. So the second 2 panels are looking at western toads, again in Glacier and Greater Yellowstone. And here we're seeing some differentiation. The toads are clearly spawning or breeding in beaver ponds. But again, these occupancy rates are pretty low. The third set are tree frogs, species of tree frog in Rocky Mountain National Park on the left, and Greater Yellowstone. And actually, that first year, they were choosing sites without beavers. And then the rest of the years, there's no differentiation. So tree frogs really didn't care where they were breeding. And then finally, the critter that I'll be talking about a little bit more for the rest of my talk is Ranuludiventris, or Columbia spotted frogs, both in Glacier and Greater Yellowstone National Park. You can see this species is clearly choosing to breed and be found in beaver ponds. So the next question is, does this trend translate further south into the Great Basin to the populations that we were studying? So just to orient you a little bit to the distribution of the species. Oh, yeah, I got a pointer. This was a genetic study done in 2008 by Chris Funk and others. And they found some genetic differentiation between populations of spotted frogs in this neck of the woods we call the northern population. Here's our glacier frogs up here and our Yellowstone frogs here. There's also some populations down here in Utah that are unique. And then our Great Basin frogs here. And that's what I'm going to focus on a little bit more today. So here's a zoomed in map where we find Columbia spotted frogs in the Great Basin in green. Here's some of those Utah frogs here and northern frogs dipping down here. So as you'll notice, there's a lot of green dots here, hundreds and hundreds of sites over 10 to 15 years. So a lot of data have been collected, not only demographic data on populations, but also a lot of habitat data. And in 2015, we being the Fish and Wildlife Service, had to make a decision on whether or not to list this species. Columbia spotted frogs have been on the candidate list to be listed under the Endangered Species Act since 1993. And it kind of been languishing there, but it gave us a lot of opportunity to go out and collect a lot of data, do a lot of things for the species, which made it nice. So like I said, we had 10, 15 years worth of data, and we didn't really know what to do with it. So we went calling to David back there, and I just said, here you go, David, tell us what this all says. And he did a fantastic job in a very quick amount of time, help us make sense of all this information. So as I mentioned, our listing decision, we wrote a species status assessment report that took in consideration all this information. And from a habitat standpoint, we were seeing a lot of variability on the landscape where we were finding frogs. So this panel up here is from the Ruby Mountains outside of Elko. Again, that's a typical beaver colony type habitat. And we have central Nevada here where we have springs coming out of the mountainside, creating a natural stream here. And then us biologists went out there and dug a bunch of holes out there in this wet meadow, and frogs really like that. And then in southeast Oregon, we have these really flashy systems that just can blow out, and then when low flows come, we've got these pools here. And then another picture of central Nevada where this is a natural stream channel with all this emergent vegetation and these nice deep pools that the frogs like. So this slide has a lot of information, so bear with me. I'll try and walk us through this. So this is from one of the papers that David published here. On our y-axis, we have the probability of occupancy. So the higher the probability, the more likely frogs are there. And on the x, we have emergent vegetation. As I walk you through these next couple of slides, I want you to think about how do beavers contribute to some of these habitats where we're finding a lot of frogs. So what we have here are 4 different habitats. We've got lotic or stream habitats with only with fish, but they were non-trout fish. Okay, so our native red-side shiners or speckled dace or suckers, so non-trout. And then we have stream systems with trout and other fish, stream systems with no fish, and then lintic or ponded sites that are generally off channel, not connected to streams. So for each one of these, we had 3 different depth categories: 2.5 meters, 1.5, and a half meter. So what you can first take from this slide is the shape of all these lines are the same. And you get them occupancy increasing to some level of emergent vegetation, and that either levels off or drops back down. So these frogs are choosing sites with emergent vegetation. And then if you take one habitat type, so let's just look at the streams with fish, non-trout, they are preferring these deeper sites for cover, overwinter habitat, you name it. Here's the only site that had trout, so we don't have these depth measurements, but the same shape here. An interesting note is this lotic, no fish detected. This usually when you go out on these streams and you sample it, you don't see any fish. The first thing that comes to your mind is this is not a perennial stream, because there should be fish there. So again, these really shallow streams really aren't perennial, and you're not finding fish or frogs. And these deeper sites tend to be more perennial, so water's sticking around a lot longer. So again, how do beaver manipulate these habitats? They create deeper habitats, more permanent water, and once you create these ponds, the emergent vegetation comes in and creates wonderful frog habitat. So let's look at this hydroperiod thing a little bit more. Again, same publication here. We split up this table into the 3 states, Idaho, Nevada, and Oregon. And all of our sites were either temporary or ephemeral and permanent water sites. So here's just the number of sites visited, number of sites occupied. And these are the numbers I really want you to look at over here, is the proportion of occupied sites. And as you can see, they're really choosing permanent water. It's an aquatic frog, it's kind of a no-brainer. But again, beaver tend to create these habitats that keep water on the landscape a lot longer. So 86% of our sites were associated with permanent water. In Idaho and Nevada, it was 80, and Oregon, all of the sites were permanent water. All right. So then we just looked at, well, are they in beaver ponds or not? Again, same publication. This top graph up here is from sites in Idaho. And this is based off of about 80 different sites. And you can see beaver ponds here, reservoirs or stock pond, spring seeps, streams, and wetlands or marshes. And again, on the Y, this is, again, probability of occupancy here. The letters just tell you if they're statistically different from the other ones, from the other different sites. So again, in Idaho, all the sites visited, beaver ponds were occupied. So clearly they're choosing beavers. Down here, this is the slide from Nevada. This is based off about 750 sites, so a much more robust data set here. Finding the same thing. So you got beaver ponds, inactive beaver ponds, lakes, springs, streams. Again, statistically significant, they're choosing beaver ponds to live in. So when all is said and done, beaver ponds had the highest occupancy rates of all available habitat types in the Great Basin. Consisted of 57% of all occupied sites. And beaver ponds were, depending on the state, they were found in 11 to 66% more likely to be occupied than streams without beaver ponds. So to summarize, this should be no surprise to anybody in this room. Beaver are ecosystem engineers. So how do they create frog habitat? They increase the water permanence on the landscape, and they increase water depth, which are clearly important characteristics for frogs. They increase the shoreline area, which I really didn't talk about a whole lot, but I really like this photo here. This is from the Ruby Mountains again. If you can picture that single thread stream coming through the middle of this and the amount of shoreline area that a simple stream would have compared to this ponded area, you can see how much more habitat it creates. And then when they build these ponds, this emergent vegetation really comes in, and that obviously was very important to frogs. And then when you get these beaver complexes here, this again is that same site, just an aerial photo here, really increases that connectivity of occupied sites. So instead of having isolated populations only occupying a few pools in a stream that they like, these colonies really create large connected habitats. And before I finish, the importance of beaver on the landscape is becoming more and more accepted. And one way I've seen where this is really shown is with the state wildlife action plans that every state has to write. If you looked at the first iterations of those in the mid-2000s versus the second iteration and how they've dealt with beaver in some of their plans is pretty striking. And I looked at all the more recent ones from Idaho, Oregon, and Nevada, and all three of them mention the importance of beaver to the conservation of Columbia spotted frogs in their state plans. So I think that's a really big step that the states have made, and just goes to show you how important the beavers are going to be for spotted frogs, particularly into the future with changing climate, potentially warmer air temperatures. We saw in earlier talks that people asked, well, don't beaver ponds just heat up the water? Not necessarily. And that water permanence on the landscape. So even if, let's say, precipitation doesn't decrease but stays the same, it just changes form from snow to rain. Well, if we have beaver dams out on the landscape, that water might not just run off, and it might stay on the landscape longer. So I really see management of beaver really lockstep in the conservation with this particular species. So with that, I'll end there and answer any questions.
Thank you.
One question, if anybody has one. Yeah. Yeah, I'm glad you mentioned that. When Kent wrote the the abstract for his talk, he mentioned the threatened Lahontan cutthroat trout, which basically overlaps many of these same areas that the frogs have. And I didn't have a lot of data to show, overlap beaver ponds on with Lahontan cutthroat, but the folks that know where cutthroat are have seen the fish really respond to beaver habitat in a positive way, particularly through this nasty drought we have, this 4-year drought. Streams that normally went dry, if there were beaver there, they had water, and the cutthroat had those refugia there. So most of our aquatic species benefit with these beaver. So thanks for asking that question. Thank you.